In this example, we are going to be doing a word problem involving vectors, and it's geometrically defined because we're not going to be talking about any coordinates whatsoever. We're not going to draw it on a grid or anything like that. That would be algebraically defined. So we're going to try to figure out finding the magnitude of a resultant force. So our picture is going to be everything. We got two forces, 15 and 22 newtons, and each newton is about 0.225 pounds of force. That act on a point on a plane. The angle in between them is 100 degrees. Then we want to find the magnitude of the resultant vector. So picture is going to be everything. We're going to start by, and there's a couple different ways that we can draw it, but I'm going to try to make this as straightforward as possible. Where on another problem, we're going to have to tweak our drawing a little bit. But let's say we have this, and this represents the 15 newtons. And then we have this 100 degrees between them. And so we would have some other vector, maybe like that. And that angle is going to be 100 degrees between the two. But this one is 22, so I'm going to try and draw it a little bit longer than hopefully what that one is. So that one's 22, just to try to keep it somewhat to scale. And then what we're looking for is if you have a force pulling in this direction and a force pulling in this direction, the combination of the two is going to be some force pulling in that direction. So to figure that out, we'll actually put it's like we're going to add the vectors together. So if we take this vector and add it on to this one, it's going to look something like that. And then if we took this one and added it on to this one, try to make it straight, it's going to look something like that. So the reason we do this is because the vector in between, like if we connect this to this, that is your resultant vector. So that's the pull and the direction that's happening with these two forces happening on those two different directions. So if you had a chain pulling here and a chain pulling here on some sort of a stump or something, and if it finally gave, that's actually the direction and the force of the direction that it's going in. So we want to figure that out, and we're just looking for the magnitude. Okay, so we're looking for kind of the force that's happening in that direction. So how do we do that? Well, we have these triangles that are broken up, and it's not as straightforward as just cutting this thing in half. So it's not 50 degrees and 50 degrees. If this was 15 and 15 or 22 and 22, then yeah, that would be split in half, but it's not. Another thing you actually have going on is the fact that you have, and if I just kind of ignore this piece to it, you have a parallelogram, which is important because if this is 100 degrees on a parallelogram, the top and the bottom are parallel to each other, which makes these two angles add up to 180. They're supplementary. So if that piece is 100, that forces this piece to be 80, which is good because this is 80. And then this 15 is the same as this 15 up here. So we're looking at this triangle. It's not a right triangle. So we can use law of sines and law of cosines for it. So if we want to just focus on that, we're looking at this being 22, this being 15, and this being 80. And this is the vector that we're looking for. So this is a law of cosines. It's not a law of sines type of problem. First, it's not a SOHCAHTOA because it's not a right triangle. I don't know if these angles are 90, and I doubt that they are. So you have a law of sines or law of cosines potential, and this is a law of cosines because law of sines you can only use if you can do one full fraction, and we don't have the side across from the angle, and we don't have these angles across from the sides. So it's got to be a law of cosines. So our problem is going to be v squared is going to equal 22 squared plus 15 squared minus 2 times these two values if I'm doing law of cosines. And then times cosine of the angle across from v, which is 80. So good news is we can just throw all of this right into the calculator. And v squared is going to get us roughly 594 point a bunch of values. And then we're going to square root that 594 and a bunch of values. and get V to be about 24, and it's 24 newtons. So that is the amount of force that's going in this direction of 24 newtons. All right, so that was finding a resultant force between two different vectors, two different poles. We use law of cosines to make that happen, and we also use the properties of parallelograms in order to get an angle that we could use law of cosines. All right, so that was vectors, geometrically defined word problem.